Hello, welcome to the Thursday afternoon AquaStax hour with me, Long Steve. Okay, let's get going. I'm going to jump straight into it today. Hopefully I'll think of some things to talk about while I'm coding. So, those of you that were around on Tuesday evening, which was my last stream, might remember that I had some working collision code that was going to collide with the edges of the grid. Let's fire it up in Chrome, waiting for the thing. Still waiting for localhost. Okay, here we go. So I had some I had some boundary detection code which detects the bounds of the blocks that I had defined, and there's a blue and kind of a cyan line there that denote the left and right boundaries of the block, so I can't move it outside the grid, which is rather handy. Also, I can't rotate it if it will fall outside the grid after a rotation. I'm going to do something about that today, because I'm pretty sure that's rather awkward when you're dropping a block down. You want it to be able to rotate and then have it shifted away from the side of the screen. Right, so we're going to dive straight back in. Let's see, where was I? So inside my tile, this was the getTileBounds function, and it was determining the left and right bounds. Now I'm going to extend it so that it determines the, I would say upper and lower bounds, but actually we probably only really need the lower bound. That way the block can land when it gets to the bottom of the grid area. So let's see, either I'll extend it to include the lower bound, or we'll write another function. I've got left bound and right bound. I can't use LB again, can I? I suppose I can use bottom bound BB. Yeah, that'll do for now. And this is, I'm not going to necessarily want to do it in the Y, am I? I'm going to want to do it in the, oh no, I am going to want to do it inside here, but let's see. Determine bottom. I'm going to put that in quotes. Bottom or lower bound. 99. I guess it's going to be working, so these left and right boundaries, so this bit of code works its way from the left to the right until it hits a non-empty block, or a non-empty cell within the tile grid. And interestingly, I wonder if it's actually, I'm having a thought, I wonder if it's not going to work quite right. I've just spotted what might be a bug where it sets the first one it comes across, but of course we're working our way from left to right in the grid, and from Y from bottom to top, and if it hits a boundary at one point that's before, let's see, and on the lower bound, yeah, if it hits a point on the lower line of a tile which is non-zero, it's going to set LB, but potentially there might be additional grid bounds. Confusing. Oh, hello, Newton1. Good to see you again. Good to see you. I just jumped straight into it today. I am extending my boundary checking function, which returns the boundaries of the tile. You can see the left and the right boundaries here, so that the tiles can't go outside the grid. But I've just realized there might be a bug. But at the moment it didn't seem to identify itself as a bug when I tested all the different tiles out the other day. Hi Drubnier, good to see you. Hope I pronounced your name right. I'll not worry about that being a bug now. It may not be a bug. It'll need too much fiddling around and thinking to get it to work. Anyway, we're going to look at the bottom boundary now. So hopefully the block will land correctly on the bottom of the grid. rather than at the moment where it sits off the bottom by one cell. So, grid pos. We're looking, so this is the right boundary, so I'm going to determine the lower bound. So we want incrementing y. I think it's just going to be plus x, similar to this one here actually. That looks too easy. That can't possibly be right. I will see what I think it's doing. I might have to do it in a different loop. It's not x, it's going to be y for a start. No, that's actually, that might be what it is doing. Right, so let's return left, right, bottom. And we can draw this inside the grid by using our highlight. Bx, we'll call that. Bounds.bottom. Draw rect. What do we want? 0 bx. And then we want 0. Actually, we want block size times grid size bx. It's going to actually it's going to be bx times, yeah, we already times the bounds at bottom by block size, so it's just going to be bx. Okay, and we'll have another different color. Try and find one I haven't used before. Got a bit of a yellow, so it's working out the bottom boundary. If I shift it to there, it's still doing the same thing. It should be showing me a line one cell up from the bottom, really. So that's obviously not working. Let's go back and look at tile. So it's y times grid size plus x. If it doesn't equal 0, we're going to use y. Now, this might indicate the bug that I was thinking I had earlier. Let's see, we want to do this every time, but rather than test it, or stop doing the test each time through the loop, we want to do if does not equal 0, so if the block is full of something, and so let's say y is, we want to check if y is less than what we've already set the boundary to be, I think. And if we move that out, I should probably do the same with these ones. Nope, it's still doing the same thing. Ah, that's going, oh, I tell you what it's doing, it's, it's upside down, isn't it? That's now got the block, sorry, the block, the lower boundary in where the place would be if it was actually the upper boundary. I wonder if I've got my code upside down. Does the grid data represent bottom left or top left? So I can't remember. I should have documented what my tile data actually meant. Let's see, loop for each rotation. Just going to program by a bit of trial and error. if I do, because we're going from 0, if I do bb equals grid size minus y, that should invert it. Might be -1. Yeah. Nope, still not working. So that's correct. That's kind of where I want it to be. But that's not. What I want to do is visualize where the code is looping over. Let's see. So the block that's defined is this first one, and it's 4. I'm pretty sure that's the bottom left. That's bottom right. Ah, no, that's top left. 4 is a single triangle point, so that is top left, top right, bottom left, bottom right. So for some reason my grid data is defining the tiles from the top left. Not sure why that is, rather strange thing to do. So we want top. So we're going from the top. And if it's not equal to 0, what we actually want is grid size -1 minus y. I'm pretty sure here. Okay. Now I'm subtracting 1 when maybe I don't need to. Grid size minus y. Or is it just y? We'll get there in the end. Okay, that looks better. Initially, there it is. So what my boundary means, and I should probably document this now while I'm doing it, is the left bound and the right bound are the number of cells from the left-hand edge. So let's document this. And is it from the bottom left? I've now decided it is from the bottom left, even though the grid data is defined from the top left. Work out the number of grid cells from the bottom left that are empty of tile or filled tile cells, grid cells, filled tile triangles. And let's have some example, e.g. So let's do a bit of ASCII art. Vertical bar, there we go. Right. So if we've got this first tile, it's 0, 4 is the point. So let's call that 0, 4. And the one below it, I'm looking here, is 31. Right. So that's what it looks like within its bounding box. It's a 2x2 tile, and it looks like the block itself looks like that. A square with a triangle stuck on the top of it. And the left bound, so left bounds information equals, so left is going to be 0, right is going to be 1, bottom is going to be 0 in this instance. And let's double check that by breaking into the debugger and seeing what it actually is. Grid, and we look down and it's here. So bounds, hover over it. Bottom left, so right is 1 and everything else is 0. Yeah, that's what I expected. But if it's rotated, let's rotate it to that position. Then let's see what it gives us. Yeah. So that's going to be, the 31 is in there, and it's not 0, 4, it's going to be rotated to something else. So it's going to be, need to remember my triangles, it's going to be 0, 1, that top triangle there. Ooh. There's 0, 1 there. And actually it's not even 31, I don't think, it's something else. Oh, hi, Naruto, good to see you. Right, because when it's rotated, the rotations occur, and it's going to be 2 different triangles. Oh, and Kailu as well. Oh, good to see you. There, so it's going to be a 34. No, it's not. It's going to be a 42. It's going to be that triangle and that one. Not that they actually matter, but I will put it in there. I'll put 42 in there. 42. So when it's that's when the block is rotated to that particular. Actually, I should do this on the same line, shouldn't I? Really. We've got left is 0. Yeah. Right is also right's going to be 2 at this point, I believe, and bottom is going to be 1 because the right is 2 cells along from the left, and the bottom is 1 cell up from the bottom. So let's check that. Yes, so right is 2, bottom is 1, and left is 0. So it looks like I'm calculating the bottom boundary correctly now, at least for this instance. I'm going to tweak this bit of code as well, so that these left and right boundaries work the same way as the bottom boundary does. And what I want to do is, so it's not 0, and x is lower than whatever we've got LB currently set to. And I think, is this going to work as well? X is less than RB. It's always going to be less than RB, isn't it? It's going to be grid size minus X. Whoop. I'm probably going to break things now. what I was concerned of was that irregular shaped blocks wouldn't give me the correct I don't need that, do I? Wouldn't give me the correct boundary values. Yeah, right boundary is wrong there. Left one's still okay. That right one is not quite right yet. It's got to be grid size minus x is less than RB. Grid size minus what? I'm working in from the right hand edge, and it's counting the blocks for the how many. Basically, this particular thing is counting how many, or if there's a empty cell in the positions moving along from the right hand edge of the grid. Now, let's try to figure out how this works. It could be greater than, because if I'm working in, then definitely it might be greater than or equal to, but that won't trigger the first time round. I'm definitely working from the left. Okay. Which editor am I using? I'm using SlickEdit, Newton one. It's a app that's been around for many, many years. I've used it on loads of platforms for a long time. SlickEdit.com comes from SlickEdit.com. It's a commercial tool. You have to pay some money for it. I've used it for so long that I have an ongoing license. It does look old, yes, you're right. It took them a long time to create a Mac version that actually looked anything like a Mac app. It used to be, because it was written for Unix systems initially, the guys that created it made a Mac version, but it used the Unix subsystem, and it looked pretty bad. I'm just used to using it. It supports lots of different programming languages and project types as well. So where was I? I was trying to figure out. Hi ZX218, good to see you. Trying to figure out where my how to set them a right boundary correctly. So and KLChan85, a couple of numbers there. ZX218 and KLChan85. I want to set my boundary up as if it's, where am I doing? I'm trying to figure out, yes, puzzle games. I'm trying to figure out the block dropping boundaries so that I can move my block left and right correctly. The way that the blocks are defined is a little bit esoteric. It's kind of using some old code. And I've got the left and I had the left and right boundaries working okay in most situations, but the right boundary currently isn't quite working. The idea being that when I have the right boundary figured out correctly, then I can't move the block past the right-hand edge of the grid. And also, when I've got the lower boundary set correctly, then I can land the block on the bottom of the playing area, the grid correctly. And it's looping over the x's, and it's working out whether or not there's an empty cell in the position on the right-hand edge. And if there isn't, it sets that right boundary to grid size minus x. So, for example, it should set it here to 2, but when it loops over again, I want to make sure it doesn't set it a second time. But I want to make sure when it goes down to the next row that it does it. Actually, no, I'm okay. I was forgetting how my old code was working. I think I'm okay because it's looping. it's going over the x coordinate, so it's going along, then it's going down, going all the way down. As soon as it hits something, it's going to stop. So the actual left and right boundaries were correct when they were doing the if LB does not equal 99. Oh, actually, if it equals 99, we haven't set the value yet. So then it does that. And I can ignore that bit. So I'm going to go back to doing what it was doing before, because I thought that worked. Equals 99, do that. But this bit's different. I could either do it outside of in a new set of loops, because I'm determining the lower boundary. I want to keep going until it finds basically the lowest point. I'll try this with different blocks. Oh, hi, Sinuccia. Good to see you. Hope I pronounced your name right. So, it's looking better now. Let's go into the grid. I can probably turn off this grid position, because I don't need that at the moment. So all I'm doing now is drawing the boundaries. There it is. And let's see if I can get it on the bottom of the screen, or the bottom of the grid correctly. So in here, we continue to move the block down and collide block with grid bounds. If that comes back with a fact that it's collided, it stops moving it. Okay. And it continues to drop it. Basically, it just moves it down all the time. So I want to extend collide block with grid bounds to include the bottom as well. Collide block with grid bounds. Here we go. So if new pos dot y let's see, new pos dot y plus, am I doing exactly the same thing as I'm doing above, or am I doing something different? I want bounds dot bottom times block size is greater than 0. If that's less than 0, no, if it's, if we're less than 0, we return true. That should trigger when the bottom, or the y position, plus the bottom boundary, which could be 0 or it could be 1 grid cell high, goes below 0. Right. What's stopping it from, I was wondering what's stopping it from hitting the bottom already. Something is stopping it hitting the bottom. Prevent drop off from the bottom of the screen. I can get rid of that now, because that's handled by collide block with grid bounds. And it should take into account the bottom boundary. Let's do that. There it is, and it sticks on the bottom. Excellent. And I can roll it around. I can't rotate it now because, oh, is it crashed? No, it hasn't crashed. Can't move it either. Possibly because it's colliding. I should be able to still move it left and right at least. No, it's because it's now in collision with the bottom of the grid all the time. So I can't actually move it anywhere. That's the next thing I want to fix, is the preventing moving when it is colliding. So that goes there, and it stops. Hopefully most of these will just work. This one should just land, yeah. That yellow line is telling me my bottom boundary. see if that one will land on the ground. Yeah. Oh, it slows down when I hit the bottom. Possibly something to do with the collision code. Why is it slowing down? I shan't worry about that. What I can do now, though, is insert the data into the grid when a block lands. Then I can actually test the collision against the grid, against data within the grid. So I might actually be able to stack up blocks. That'd be a good place to get to before the end of the day, I think. Stacking up blocks. Right. So I had a collide block function which did a funny thing. It didn't actually test for collision. It inserted the block data into the grid. Here we are. Take a block that's falling or moving around and insert its data into the grid. So do I call collide block anywhere at all yet? Oh yeah, it is called. Ah, that's when I hit spacebar. Okay. So at the moment I have to hit the spacebar in order for the collision to occur. And it creates a new block and then starts the loop again. Right, so there is actually data going into the grid. And new block doesn't hide the old block, does it? It just leaves the old block in the grid where it lives. So what I could do, it's always optimistic to think you can do something and then you realize you've actually got to work out a few other things first, so I may not get to it by the end of the day. But collide block inserts all the data. Got collide block with grid bounds. What I also want is collide block with grid data as well, and that will give us whether or not it's. Oh, I've done it now. That'll give us whether or not there's something underneath the block. So let's see if I can do a new function. Collide block with grid data. I'm going to change this because I'm going to want a collide block function that calls several other subfunctions a bit later on. But this one is, I'm going to call this insert block into grid. And then for the moment, just put it in here. Right, insert block into grid. Anybody watching my old streams back might notice I've had a haircut today. If I lean forwards a little bit, you can even see the back of my neck. It's my semi-annual haircut. I've always had long hair since I was young. It was really fluffy and long when I was really young, but I think it's still reasonably adult. Right. So we have back up here. We have some code that figures out where the grid is, don't we? Ah, Cheesecakes. I don't know how to pronounce that, but hello, welcome to you. So these boundaries that I'm drawing, I'm actually using the falling block directly, and it's getting its tile boundaries. And how am I drawing this? I'm drawing the position, because the blocks that are falling, they actually have this boundary information is drawn on the grid itself. Ah, hi, Joslo. So I must be limiting that to grid positions somewhere. So LX is left boundary, grid pos highlight. Am I not setting the position of the grid pos highlight? Where does it set the position of that? Ah, here we go. Get grid position for node. That's what I want. Get grid position for node. And then that sets the node itself, and then I'm drawing the boundaries. Right, so I want get grid position for node. Interestingly, that's a node. Get grid position for node. But I'm not passing it nodes, I'm passing it points at this point. So I might just want to borrow this bit of code here. I could do get grid index for point. I do need that. Then I can just do that, can't I? And get grid index for node can just be return get grid index for point. Now, is it node.position? I think it probably is. Nope. It's not position, I guess. Why have undefined? It's going to be, let's get back up the stack. I probably need node.get position, don't I? Ah, yes. That's more like it. So get grid index for point, get grid index for node. There's get grid position. So what's that doing? Is that what that's working out an actual another point, isn't it? I could do get grid position for point as well. I can see myself swapping between nodes and points all over the place. So point turns out to be the better thing to pass into these functions. Get grid position for point. P. This is going to be self dot get grid position for point. Node dot get position. Right, so now down here I can get the position or get the grid index. Get grid index for point is what I want. Get grid index for point. Self dot falling block dot get position. Although actually I'm going to want new pos. Yeah, just do new pos. pause. So that gets me a grid index. So if what's grid position bx? That's actually a pixel position. There's grid position for point, grid index for point. Index. So this spot here is going to be the bottom left of the, well, it's going to be the bottom left of the block that's falling. And the point in the grid, isn't it? So it's going to be like there, that point there, and that point falling down. So that's a good place to start testing for collisions. I could actually, let's work this out bit by bit. I could just do if, let's see, we've got self dot, so insert is game grid, isn't it? Self dot game grid index. If it doesn't equal 0, then return true for a collision, else return false. I should actually document this. True if collision occurs, false otherwise. Yes, same there. So collide block with grid data, collide block with grid bounds. And for now, I'm going to add collide block, new pause, new rotation. Ooh. Hi, Yana Seattle. I think I saw you the other day, actually. Or you saw me. New rotate. So what we're going to do is we're going to call both block collision functions. If, just going to leave the old var self equals this. If we're colliding with the, if we collide with the grid boundary, return true. Otherwise, if we're colliding with the collide block with grid data, if there's stuff already in the grid, return true, else we return false. And then back in here, we can just change this to collide block. Let's get rid of that. Right, let's see what happens. Nothing at all. Pretty common that. Self.get grid index for point is not a function. Did I call it the wrong thing? Where is it? Line 250. Oh, what have I done here? Hang on, I've got some syntax errors. Still the same. Self.get grid index for point. Did I call it something else? Get grid index for point. Yeah, there it is. Either I'm going blind in my old age and I can't see that I got a typo there? Oh, of course. I've forgotten the var self equals this at the top of the function. Okay. Now it's moving. Oh, is it because it's outside the grid? It's probably because collide block with grid data is returning something. New pause. Let's see what's going on. Right. So collide block with grid boundaries is false, as I would expect, but this one's returning true. So let's see what it's doing. So what's index 301? Game grid is 606. There should be nothing in game grid at all. Huh. Of course, it's going to be undefined. I suspect doesn't equal 0. If we even put something in there, where is game grid? Game grid wide times high times 2. It's definitely a new array. Let's var grid pause equals this. I'm assuming it's an integer. It's probably going to be undefined because there's nothing in there yet. Yeah, grid put is undefined. So it does not equal 0. What's the best way to fix that? Probably we'll do that, I think, for now. Right, it's moving. So it should just stop when it hits the bottom. Excellent. Now let's put... I'm not going to rotate it just yet. If I put it there, this next one should stop falling when it gets there. And it has, it's stopped on top of that block because it's testing the next block down, finding that it's got a piece in it, and then won't let me move. And I can't move to the left because it's testing the left-hand position. Excellent. So if I do that, place it in the block, so that should land on top. If I move to the right, though, I think it will fall off. Oh, I can't move to the right because it can't move. I'm just trying to find out where my test code is going to go wrong. What does that do? Will that land? Yes, that lands there because I'm not taking into account the boundaries. So there's a bit of work to do yet. But at some level, it's almost working. I can stack up blocks. Oh, I couldn't stack that one up. It moved a bit fast. I wonder what happened there. That's interesting. So that one's stuck there. Yeah, that's what I would expect. That's stuck there. That's stuck there. But I'm holding the key down as well, and it stops there. Possibly because it's got to the point where I'm trying to fast drop it, but it won't move. Yeah, I'll need to work that out at some other point. I'm close though. Actually got something going on now. Will that land there? Yep. Yeah, so without the fast drop, ignore the fast drop, the blocks are actually landing on top of each other. Yeah, that's not going to do it. Right. Well, every day a little bit further on. I know I'm only doing this for a couple of hours a week, but it's getting there. I can see a little bit of progress. I spent a bit of time sidetracked by the rendering architecture of Cocos2d-JS, but now things are moving a little bit. Yeah, block that there. Oh, that one went straight through. Of course, it's only testing one position. What I need to do now is test basically the cells that are covered by the block by using the boundaries. Now, I'm pretty sure I had some old code that did this, but I'm not going to go and look at it. What I've realized is that by looking at my old code, copying and pasting it in and doing stuff, I end up writing stuff that's like this, which is a bit esoteric. And I have like the definition of the old blocks in hex numbers and things, and it's probably, I mean, I did all this because we didn't have any structures and classes and things like that. We had to just use arrays of integers to define everything. But I don't need to do that now. So I'm probably overcomplicating things. I'm not going to change all the stuff I have done, but I'm not going to worry too much about digging into my old code, apart from occasionally I might play the old game just to see if whatever I've written now is working in a similar way to the way it used to work. Right. Let's see. Is there anything I can quickly do? So I could go for... So all this is doing is testing the grid index at the point of the block. So what I actually want to do is I want to use the boundary, don't I? So let's come back up here and pinch a bit of this code. Copying and pasting this stuff is pretty horrible. What happens is after you've done a few things like this, after a couple of days or using the functions, you realize that you actually want to refactor them like I just did here. So you end up not copying and pasting too much code. Or you delete some code and then refactor it. But it's only after you've written the function and you've used it for a little while do you realize the most appropriate points to use it and what it's used for. Anyway, let's do this. Get tile bounds. I'm going to want basically a function that will return me the cells in the grid that are effectively occupied by the block that's falling down. That way I can just test those cells, and I can use the boundary, I can use the tile data for the cell. So in the case of this block falling down here, I can use the fact that it's got these three are filled and 3 is empty. So that I just realized that's what I'm probably going to need to do. Hi V Rubin, good to see you. Just getting a bit of a dry mouth here. Use my mute button. I've got my microphone close to my face again today. I've been using my lapel mic for a couple of streams, and I wasn't sure. I listened to myself back, and I think it was a bit muffled. Hopefully, I'm a bit clearer today. But you can pick up all of the subtlest sounds, like slurping of tea. Right, let's see. Yeah, I think. So I'm looking at these functions, collide with bounds, and the same up here where I was drawing the boundaries. I might as well write a function which will return me the list of index positions within the grid that the node that's falling down is actually occupying. And actually, that could be a number of different grid positions. For example, if I can stop one of these blocks halfway, let's stop it there. Oh, I can't stop it there. Can I break in the debugger at some point just to see what's going on? If I hit it there, what I really need to be testing is actually 3 blocks. I only need to collide that block there, that cell within the grid, that cell within the grid, And in theory, that cell as well. Those are the three overlapping blocks at the moment. It's only when the block that's falling is perfectly aligned with the grid does it equal 2 blocks. At most other times, it's going to be 3. Luckily, my left and right movement jumps grid cells each frame. There's no in-between movement horizontally, unlike vertically, which is moving down at a certain rate. So I won't ever need to test the cells to the side. It's just going to be the up and down ones, or the ones above and below. So for example, although it's only one cell high at this point, there's going to be at least 4 blocks or 4 grid cell positions to test. So let's see if I can figure out a function that will return those for me. Let's put it up here. Get grid cells, get grid index position, grid indexes, index positions for block collision. That'll do for now. Function we need the block, we need the position, and we need its rotation. And what we're going to do is get the grid index first. Actually, first thing I'm going to do is that. Then let's make some variables names that are reasonably verbose. Bottom left index is going to equal to let's pause. Okay. How do I know if I'm exactly aligned? We'll work that out in a minute. Bottom left index for bottom left index, and then we want to do we'll get the grid bounds as well. That's always useful. Get tile bounds. Probably going to need those. So tile number, get tile bounds, that's rotation, and block size, yep. So indexes, the first one is going to be the bottom left. Then we're going to want to loop over the block's grid size. Completely distracted by a picture popping up there. Let's go back to where I was. Grid data, isn't it? So it's tile. Then let's see. We want tile. I suppose I could reference the tile, couldn't I? We've got tile number. No, we use. So I'm going to want to borrow these little loops for looping over the X and Y for a tile data. Actually, I could do that, couldn't I? Var tile tile num. Grid size is tile grid size. Yes, right. So we loop over that, and then we have for each position. Let's borrow this. Not going to worry about that. This is where my confusion comes in as well. It's top left, isn't it? Right. Just realised Dropbox is probably going to come in and do a bunch of stuff that I don't want. Quick Dropbox, right. New index is going to be index bottom left index. So it's going to be bottom left index plus x is the obvious one. But then it's also, and in fact, if I go y first, bottom left index plus x plus, and it's y times, now this is interesting, it's self.blocks wide, blocks wide, bottom left index, that's indexed into the grid, yeah, plus x, so our grid is indexed bottom left, but every time we go up by one line in the tile, we want to add self.blocks wide to it. Yep. And then we can do, well, we can just do indexes. For now, this isn't quite the full function, but it's a start. New index. So that will give me the indexes in the grid that overlap the entire tile, not just, I mean, there are bits of the tile that are empty, but for now that's a start. Turn indexes. So what I can do, get index positions for block collision. If I come down here, and we're sticking it in here, aren't we? We want to do grid pause. Indexes, or indices. And for each one of these, we loop over. And we test this. If we get a hit, we return false. Sorry, if we get a hit, we return true. Otherwise, we return false. So, give that a try. Now, this won't quite work. This will work, but some of the blocks will collide when they shouldn't. Let's see, what did I break? Cannot read property 0 of undefined. Oh, okay. 198. Is that in tile or? Okay. What did I do here? Broken something? Property 0 of undefined. Did I pass in a rotation that's not defined properly? Collide block with grid data. If I toggle, is that the one? Which is the thing that says break when an exception occurs. Maybe it's not that. Is it that? Ah, Pause on court exceptions. Okay. Here we go. Right, we're in. So yeah, rotation is undefined. Why is rotation undefined at this point? Rot is not passed in. Get grid index positions for block collision. I obviously haven't passed it in. Why not pass it in? Ah, right, okay. Collide block. P is position. I could default that. Let's see, let's do a let's borrow from up here. If I put it in at this level, I should fix that, I hope. There we go. Right. So now, I should hopefully, that will land there. No, it didn't. I wonder why. Will this one land? Yes, that one lands. Yes, I'm expecting it to do that. I'm expecting any collision of the boundary to collide. Yeah, that one worked. About that way around. I'm expecting that to collide. Yep, that collided. Yep. I will just reuse this debugging code. So that's the effectively the block I'm drawing. Don't need to worry about these just now. So I'm expecting any hit within that green square to cause collision to occur when a block lands. Oh, hi, Alpha Red. Good to see you. So that should collide. Now, why didn't that collide? Must be missing something there. That did okay. Yeah, that collided. So I'm expecting that to collide. Just there, exactly. Don't suppose it's hitting something off of the... Well, when it passes through the cells that are not solid. I mean, solid squares rather than triangles. Yeah, see that missed. I wonder what's going on. Let's see if I put that there. And see if something will land on that triangle. Yeah, that didn't do it. Okay, let's just quickly have a look at that. We're 10 past 4. I'm going to finish fairly soon, but I'm interested to know why that's missing that out. So this is bottom left. Yeah, we're definitely just returning a bunch of indexes here. I will double check that I'm getting 4 values within. Oh, I might even be getting 5. Yeah, I don't even need to push that on there, do I? Because we'll get we'll get the bottom left index as 0 first. Oh, hi, Links, good to see you. So I can get rid of that for a start. Let's just try this one more time. Get it near the 0 point. So that's there. So this should collide there. Oh, it did. So that works. That's interesting. These ones, yeah, they're solid squares. See if that one's going to collide, because it's colliding with a solid square. It's the triangles colliding with a triangle that seems to fail. Now I'm just going to get lots of squares. How many of them are going to get? You see, if I had been passing this to QA, they would have come back with a bug saying it gave me 5 purple L shapes in a row. That's a bug. But it's not. It's just the random number generator giving 5 L shapes in a row. Here we go. Triangle versus triangle. At this point... Oh, okay, now it's stuck. That's good. Did I really just fix it by deleting that bit of code? This is unusual. That's colliding now. Let's try that. I'm going to refresh this and see what happens. So that if it was doing what it was doing before, that should fall through. Ah, now it's falling through. Right. Let's see what's going on. Create collide block. Right. So we should have collide with grid bounds. We know that in this case, actually, that's going to return true, isn't it? Yeah. So we're not actually colliding with the block data. Let's try that again. Let's put it there. Now, triangle with triangle. So that worked. Well, let's see. Is this one going to fall through? No, it didn't. Why is it not? Some of them are colliding and some of them aren't. I'm very confused as to what's causing this collision to not occur. See what happens there, shall we? Okay. I might have to manufacture 2 blocks in a row, so I don't have to keep relying on the random number generator to give me the ones I want. So what happened? It was... So I definitely did this one first, and I tried to land a block on this corner piece. It was like that. See, that's missed it. Right, so 2 of those blocks, and the collision didn't work. So let's just put 2 of those blocks down, and we will see what's going on. So, new block 0 first. Oh, got a rating. Thank you very much. Much appreciated. And first new block. Which one do I want? It's a blue one, isn't it? Tile RGB. It might be tile 4. Yeah, let's see if it's tile 4. So I'm just going to hard code new block to give me type 4. Type. So we got that one. And then, oh no, it's not that one. Yeah, maybe it's type. Is it 3? No, 3's the it could be type 1 actually. I need a little cheat sheet to remind me of what types my blocks are. Yes, it's type 1, right. So let's put this down here. Actually, I could put it further up the top of the screen. That way. Put it there. Yes, so that's where it misses, so that's where I want to trigger the breakpoint. See if I can get it to do it. Ooh. Ah, why didn't my debug click? Yeah, that's fine. It's close. I mean, that should be pretty much where it's going to debug. Right, so that's done true. Let's go in here, see what it's doing. So, get grid index for point. Actually, I don't need that anymore. Indexes. So indexes is going to be an array of 4 positions. Yep, that's what I'm expecting. And it's 186, 187, which is probably going to be those 2 points there, and then 200, 201, which is the next one's up. And why then, if there's some data in game grid? So actually, game grid only has 187 and 188. Index, yeah, 187 should collide. So what am I testing with here? Indexes. Oh, of course. I've spotted the bug. It's not. I don't need that. I need indexes. So it's self dot game grid indexes I, and that will test the collisions on the different points. I hope. If that does, then that's a good point to finish. Right. Right. Yay, and it stopped. Excellent. So these little points, anywhere there, should stop on the corner. Well, actually, yeah, because that block in the grid was empty, it didn't actually collide until it needed to at that point. Of course, right. Let me just put the this game new block function back the way it was. Right. Bounce. So hopefully that'll just sit there on top of the thing. Ooh. Oh yeah, of course it's doing that now. So it's only testing testing all 4 squares. So any collision of those 4 squares with a block in the grid will cause the collide to trigger. We're not using the boundaries yet, so it really only works properly on the 2x2 blocks. So that one should probably sit on the edge, shouldn't it? Yeah. Sits there. That one will sit on the point. So in the old game, when you dropped a block with a point onto a flat piece like that, that would actually have caused this piece to shatter and break, and then the rest of it would fall down. So there's lots of gameplay still to do. Also, they would slide. So landing a block like that, it would slide down one more cell and then slide off. So diagonal faces, when they landed on each other, slid. And I think that would slide as well if I did that there. So a diagonal on a point would slide off. Like that, would slide down to the right. So lots of stuff still to do, but at least now there's something in the grid, and the falling block is reacting to it in a very basic way at the moment. Excellent. Okay, I think that's a good place to stop. I'll take a screenshot of that. I should take screenshots and kind of see the progression of the game as I go forwards. Let's commit this to GitHub before I go away. Load up SmartGit. If you look at the Live Coding TV page, you'll see an animated GIF of the original game that I'm remaking. And oh, hi Technobat, good to see it. let's commit this. So what do we do? Added lower bounding. It's not box collision. Lower bound collision test. COLLISION test to the falling block. Started to implement collision against blocks or block data already within the grid. Excellent. I will be back next Tuesday evening at 8 PM UK time. Do follow me if you want to get notified by Live Coding TV when that will be. And you can follow me on Twitter as well, I think. Yeah, my little thing at the bottom there says LongSteve, @LongSteve on Twitter. You can also watch most of my old videos on YouTube. I'm a couple behind on YouTube. I'll upload a bunch of them probably after this stream today, actually. Let's quit that. I think I'm good for the day. I always forget this. I need the gulp task. Keeps running in the background, and Slickhead, it doesn't like to quit. There we go. Is it still running? Gulp. Yeah. Kill 1296. Right. Thanks very much for watching. Cheers, Newton1. Good to see you again. Hope you haven't fallen asleep, and thanks for the rating. And I will see you again on Tuesday evening. Let's jump back to the intro. Cheerio, everybody.